Yes, sir.
Okay, very good. Right. Okay. Now, today, we're going to start our seminar, right? So, grade 9 science. This is the first seminar which we're going to conduct, right? So, we warmly welcome all of you to a new type seminar, right? Okay. So that you know the topic, what we're going to discuss today, right? The topic is human circulatory system, right? Okay. So on behalf of Team Comrade, me, Rehan sir, right, both. Okay, we warmly welcome all of you. Our all students are there as well as new faces also there, right? Hope you all are doing fine, right, and safe. So this is the first segment what we're going to bring. So this segment, this seminar, right, we have already provided a tute for you, right? So according to the tute, we will discuss, but a lot of things we will learn today, right? With logics, right? This science is not just a thing to study, right? Just to buy heart, not a thing like that. Okay. So this is a thing which you have to think logically, right? Okay, because each and everything in science has proved, right, from several logics, right? That's only what we are studying. So we choose today the biology part and the human circulatory system because a lot of you, right, a lot of students have several problems in this heart, right, in this heart. So that's biology, right? So today we'll begin with the biology, right? So when I tell you about the heart, what do you know about the heart? In which side the heart is there? Right side or left side? Anyone?
Left side.
Left side, right? Heart is on left side. Is the heart is like this? I love this heart. Is it like this?
No.
But this is heart, right?
Yeah, it's a symbol.
It's a symbol. Then this is not the heart. That was the heart, no? Isn't it? The heart. Okay, fine. Right, okay. So then this is not heart, right? Okay. In my assumption, that was the heart, right? So when I was thinking, like sitting here, right? I was sitting on a rock, small piece of rock, right? Okay. And I was thinking, it's the heart. What is the heart? I was thinking. But heart is an organ, right? Organ? Heart is organ, no?
Yes.
Heart is organ. Right? Situated on left side, that you know. Then what is the link between this heart and circulation? Huh? Can anyone tell me? What is the link between heart and circulation? Is there any link?
No.
No link, no? No. I should. Right, it is like this. Yeah, there's a link, right? Why? The entire blood circulation happens through what? Through the heart, right? So we're going to see today and how we have to draw and everything that we're going to see today, everything, right? So this is Mr. Hinia and he's thinking about the heart, right? So in his imagination, he's thinking the heart is like this, right? So I want to prove that heart is like that, right? Very nice heart. So this is heart itself, right? He was thinking, right? This was in 1990s. This was me, right? Fine. Now, blood circulation means actually the circulation or the circulating thing is the blood. That is the main thing. You know about the blood, right? Okay. So when you cut your hand, right, or when you get wounded, so what is happening? The blood is coming out. So that we call bleeding. Bleeding, right? So that bleeding happens because of the blood is there in several PVC pipes. No? Do we have PVC tubes in our body?
No.
PVC?
No.
Then what we call it?
Tube-like structures, blood vessels.
Like what we call blood vessels, no? Through the vessels, they are going. Fine, that also fine. Keep it aside. From where it comes, from where it goes. Now, this is going all over the body, right? This is going all over the body. Now, that is what we're going to study today, right? Okay. So, especially the main thing what we're going to study in this circulation is the blood circulation, which happens in the heart, right? And from heart, how this blood is going away and how to the heart the blood is coming, right? So this entire thing we're going to discuss in logical manner, right? Okay, now as he's thinking, right? Okay, as he's thinking, we'll get entered the session, right? Okay, now if I want to tell you, right? So this is a man. Right? This is a man. Right? Okay. This is the man. Here on his left side, heart is there. Heart is there. Like that. You can see, right? Heart is there, no? Yeah, heart is there. Get this bit back. Right? Heart is there. You all can hear me, right? Properly.
Yes, sir.
Right. Okay. Now, in our blood, right? In our blood, right? Why the main thing what we have in the blood is oxygen. What is that? Oxygen. The main thing what we have in blood is oxygen, which is the thing which provides energy for us. Otherwise, we can't do anything. Okay, otherwise we can't do anything. Right? After we use the oxygen in the blood, right? After we use the oxygen in the blood, right? What happens? The oxygen, right? Using a particular chemical equation, it is converting into carbon dioxide. Okay, it is converting into carbon dioxide, right? So when we use the blood, after we making the energy from the blood, what happens? That used blood is coming from everywhere in the body to the heart, right? From legs like this is coming, from legs like that coming and entering to the heart, right? This area, right? From the head and neck and everywhere, everything is coming and entering like that, right? Then what happens? Heart will pump the blood all over the body again, like this, right? So like that, that will supply the blood all over the body, right? That is going to supply all over the body, right? Now we're going to see how this is coming into the heart, how this is going from the heart, and then in this lesson, what we're going to study further is what is the structure of the heart, how to draw the heart without by hearting, without tracing, without using tissues, just with logics, how you're going to draw the heart, right? That thing. And what we're going to learn here is the blood transfusion, right? Okay, so after knowing the heart, we're going to see about what are arteries, what are veins, what are arterioles, what are venules, and what are capillaries. After knowing these things, we're going to give blood and we're going to gain blood, that we call blood transfusion. That blood transfusion, right? So we're going to see how the blood transfusion is happening, right? When we are donating blood, in case, right, when we give a wrong blood, that means a wrong type of blood to a wrong person, what is going to happen in his body? That's what we're going to discuss in this entire seminar, right? So in here, other than that, we're going to show you some video clips as well, right? To your perfect understanding. So this will be a, like as in theory classes, how we are doing, right? With this knot, and this is a video segments and the way of drawings and logical things like that. In seminar also, we're going to furthermore discuss this everything, right? Okay, now you know, like this will happen. Okay, now we'll see one by one what is going to happen. Right. Okay, now see here. What is this? Is that heart?
Yeah.
Is it like heart? Huh? Is
Yes.
it like heart?
Yes.
Sure.
No.
Right. So this is heart. Okay. Right. The other thing is, right, if I stay like this is my right side, this is my left side. So anatomically, we are seeing the bodies or the figures, right? Normally, if I keep my right hand on a particular side, that side I call as left side, right? When I keep the left side on a particular side, that I call as right side. So when you're drawing like the structures, like these anatomical structures, you have to draw like this. So this is the heart, right? Now you have, in the tubes, we have 4 boxes. In that one, you have to draw this, right? So I will tell you whenever you have to draw. But you see this, how I'm doing, right? So I just drew the structure like this. Right? Then what I'm doing, I divide into 2 because heart is having 2 sides. Right? Like this. See that properly. Right? This is I call as, can you tell me what is it? Septum.
Left ventricle.
Or septum. Septum, which is dividing into 2 parts. Right? Okay. Then I'm going to divide this into 4 parts actually from here. Right? So what I'm going to do, I'm going to put 2 valves there. This is 1 valve, this is another valve, this is 1 valve, this is a right? Okay, so I divide that into 2 parts as 2 valves, right? Now in Sinhala, I think everybody knows Sinhala, right? So I told this, what is this side? This is left side, right? This is right side, okay? Right side of the heart. Can you see? Right? Okay, right side and the left side of the heart, right? Now these are 2 valves which I told you. Right? Okay, for the left side, what we call in Sinhala? Can anyone tell me? In Sinhala, what we call for the left side? Vama, right? Not mama, it is Vama. For the right side, we call Dakuna, right? I'm not going to teach Sinhala, but just telling. Right? Dakuna. So here, how many letters I have? How many letters I have? Vama? 2 letters. 2. Right? So I call this valve as bicuspid valve. Bicuspid valve. Right? So this is Dakuna side. So here we have 3 letters. So we call this tricuspid valve. Tricuspid valve. See this properly, yeah? Okay. Bicuspid valve and tricuspid valve. Right. Now you see here, I'm going to draw another thing like this. Like that. And here like this. This side is bit larger, no? Is this wrong? This side is bit larger, no?
No, it is actually larger because of the muscles for pumping. That side.
Okay, right. So this is actually thicker. That area is thicker. Right. Now I have divided into 4. Actually 4 chambers. Right. So each and every structure I can name. Right. So upper 2 chambers we call as what? atriums or auricles, atriums or atria or auricle, anything, right? So upper chamber for this side I call, right? It is in left side now. So left atrium, left atrium. So this side is what then? You have to talk, my dears. This side is right,
Right atrium.
right atrium, right atrium, right? Okay. So that is left atrium and right atrium. So another thing what we have here. So this one is what? Left
Ventricle.
ventricle, left ventricle. So this one is
Right
right
ventricle. Right
Right.
ventricle.
ventricle. Very good. Right ventricle. Right. Now we have several things and we know the parts of the heart. Right. Now done. Finish. Right. So we have the heart with 4 chambers. It's left atrium, right atrium. Right. On the left side we have the bicuspid valve. On the right side we have the tricuspid valve. Tri means 3. Triangle. Tri means 3. So 3 cusps on the Dapuna side. Right. And here we have 4 chambers. Atriums, 2 atriums, 2 ventricles. So bottom chambers we call ventricles, top chambers we call atriums. Okay, now the thing's going to start. Right, now you see here, right, now I told you the used blood, after we using the used blood is going to come from all over the body to my heart. Right, now from the head, neck and everywhere, hands and everywhere, this is coming like this. Right, okay, so all over the body, from all over the body, right? All over the body means on the top part of the body, right? The vessels are coming into my heart, through the heart. Right? That all come into my heart using this one. Using this one. What is this? Can anyone tell me?
It's the vena cava.
Yeah, it's a vena cava. So it is superior to the heart, that we call as superior. Superior. Tell me. Superior vena cava. Superior vena cava. Right? Okay. Superior vena cava. Vena cava. Vena cava. Right. Okay. Now actually this is that, like the heart is like this. Okay. Now the heart is like this. No? Close something. Right? Okay. Now actually this is what here is. This is open one. So cross section is only here. Right? Not this one. Open one. Cross section only here. So this SVC is like, if you put it to here, right? Now if I close this, you can see only that part, right? So when I open, so if it was like this actually, when I open, right? When I open, you can only see this one now. Can you see? Right? So I'm closing here. So SVC is like that. And I open, you can only see this part, right? So here, this is getting enter from this area. Is it clear? Right? This brings the blood, the used blood, right? The used blood from all over the body. So if it is used, do we have oxygen there? If it is used, do we have oxygen?
No.
No
A low
oxygen.
concentration.
No.
Right? Low, very low concentration is there. Very low amount is there. Right? It is like no oxygen. So we call that blood as deoxygenated blood. What is that blood? Deoxygenated. Deoxygenated means no oxygen. Deoxygenated blood. So the deoxygenated blood is coming from the top part of the body. Is the used blood is coming only from top part of the body? No. It should come from bottom part of the body also, from legs and all everywhere. Right? Okay. So from here and all that comes. Right? Now that is coming using the downside. So we call it is coming from here. Right? That also structure is same. Here it comes and entering from here. Right? So this is superior vena cava. So this is what? Inferior vena cava. Inferior vena cava. IVC. Right? IVC. Is it clear? Right? Now we took the blood, SVC, from inferior vena cava. They don't have oxygen. They don't have oxygen. So deoxygenated blood is coming, okay, from all over the body to where? To right atrium. To right atrium. Where it comes? To the right atrium, the all blood comes. Now what happens? This chamber is filling up with this blood. Right? When that chamber filled with that blood, what happens? Right? Now the blood will start to go down by opening this valve, right? By opening this valve, what happens? The blood is starting to go down. When the blood is coming down, right? Now the blood is filling here, right? Yeah, in the right ventricle. Still the deoxygenated blood is there, right? Now what happens here? It can see a nice opening from this area. Nice opening from this area. That opening has, right? So today is a Koya day, no? Right? So we can see the moon. For moon, tell me another name. For moon, it is full moon, right? So I call Luna. If it is half moon, I call
Semilunar.
semi-lunar, right? So they have two semilunar valves, right? Two semilunar valves are there, which covers, right? Which covers this one, right? Okay, then I will tell you how the lub is coming. So that's why I won't tell you. So two semilunar valves are there, right? I'm only doing one. Now what happened? The blood came here down. Okay, the used blood is coming from the body, entire body. Avilla, after coming here, so what happened? This blood is going to enter in here. When that blood enters there, this opening comes from here and divides into two parts. Right? That divides into how many parts? Two parts. See this nicely, okay? That divides into two parts. Right? That divides into two parts. This is what we call as pulmonary artery. What is it? Pulmonary? Tell me.
Pulmonary
Pulmonary artery. Right? Pulmonary artery, actually pulmonary artery opening, right? But you know one thing, no? Arteries normally carries oxygenated blood, no? The red color one thing, no, artery we call, right? Only in the heart, right? A special structure what we have, arteries, right? Here the only artery, right? Normally if we can tell, the only artery which carries deoxygenated blood, right? If oxygen is not there, that carries carbon dioxide, right? Okay, so that is coming from this side and that is entering into this, right? Now this is pulmonary artery. So this side we call left pulmonary artery and this side we call right pulmonary artery, right pulmonary artery. Is it clear until now? What happened?
Yes,
Right?
sir.
Now,
Yes, sir.
this both valves comes into my lungs. Okay? Lungs, right? When they come into my lungs, now what I'm doing, what I did? Breathing, inhaling, right? When I inhale air, that means I inhale oxygen now, right? Now that is going into my lungs. I'm not going to tell about lungs today, right? That is going into my lungs, right? When it comes like this, lung, you don't have space, right? Shall we erase this man? Right? You go there. Let everything. Right? You know about lung, okay? Now, you see this man, small, right? Okay. So here they have, this is nose and nasal cavity, and this is mouth and the buccal cavity, and the pharynx and the larynx, right? And now here it comes like this, right? So this is the esophagus, right? That is a different track, and here I'm going to draw the next track. We have the trachea and the lungs. Okay, so it comes like this. Now when it comes like that, right, it divides into two parts. Trachea here, pharynx, larynx, and then here trachea, then divides into bronchus. Right, bronchus divides into here the three parts, and here two lobes. Right, and here what I'm having, this is the lungs. Right, these are the lungs. Right, that is the lung I have, and you see here. The left lung is little bit smaller, like this, and the right lung is like this, right? They have three chambers, and here have two chambers, right? Why is that? Because heart is here, right? Because heart is there, right? And the end of these bronchioles, right? We have bola structures that we call alveoli, right? If I zoom one of that, it is like this. It's like a football, right? If I cut the football by half, so I can see the cross section like this. Okay, this is the cross section, right? Now what happens? This is coming. This is right. This is dividing into millions of capillaries, thousands of capillaries, right? So this will divide like this. Lot of capillaries, right? They are dividing and going through these all from heart. See, now they are coming now. For this side they are coming, for that side they are going. They are going all over this, right? So when they come, so what I will draw one thing and show you. This is coming like this around this, right? Now they don't have oxygen. They have carbon dioxide. What they are doing? They have carbon dioxide. They are putting into that, right? Okay. Now what happens? Now when I inhale oxygen, see this properly, yeah? When I inhale oxygen, right? Oxygen is going here, coming here, coming, going here. So inside this, what we have? Oxygen is there, right? So what happens to this oxygen, right? What happens to this oxygen? Oxygen is getting enter into this bloodstream, right? Now then it converts into red color. It converts into red color. Now the red color means what? That is having oxygen. When it is having oxygen, what we call it? Oxygenated blood, right? Oxygenated blood. So earlier what I had the used blood without oxygen, so I call deoxygenated blood. Now this time what we have? The oxygenated blood. How the blood is getting oxygenated? When it is going through the lungs. Is it clear? Is it clear?
So your bandwidth is low.
Seriously. Is the body blood or like my voice is not clear?
The body is also blood.
It's raining today, that is a problem. Is it fine?
Yes, sir.
Yeah.
Okay, sir.
Fine, right. Okay,
Yes, sir.
right. Now, until this part, is it clear? How the blood is getting oxygen? From where?
Yes.
Right.
Yes, okay.
Okay. Right.
Yes, sir.
Okay. From the pulmonary artery, that is dividing in two parts, left pulmonary and right pulmonary artery. They are going into where? They are going into lungs. So I get oxygen here. So I get oxygen. Oxygen comes through trachea, bronchus, bronchiole, and to the alveoli. Right. So alveoli. From that nearby alveoli, there are a lot of capillaries moving. So these capillaries going like this and changing, right? Exchanging oxygen here, and the deoxygenated blood means they have carbon dioxide. That carbon dioxide is putting into the alveoli. That is why when we inhale oxygen. When we exhale, what we are doing? Carbon dioxide is going out, right? Clear? Right? That is the thing happening. So carbon dioxide is going into this one. Then this is okay, releasing carbon dioxide like that. Okay, that is releasing carbon dioxide like this. Like that, it is going carbon dioxide out. Right? So that is what happening there, right? So after becoming oxygenated, the red color is coming, the oxygenated blood is coming from here. To which side? To the left side it comes. Right? To the left side, that comes like this. Right? They're getting open at these two places. Now this is what? Left pulmonary. Now if this is artery, this is what?
Vein.
Vein, right? The only vein which has oxygen. The only vein which has oxygen, right? So it's called left pulmonary vein, right? So this is left pulmonary artery, no oxygen. Here left pulmonary vein with oxygen, right? So oxygen is present, right? Okay, so if that from left side that is coming like this to the heart, right? From the like right side also it should come, no? Right? So here from right side also that is coming. Right, that is also coming like this and getting as two branches, and they get entered to the heart. Will they enter to this one? No, they are entering also to the left side, right? So to the left atrium only, they are getting inside, right? Now what will happen? The blood will fill in this left atrium. After filling in this left atrium, now what is going to happen? They will try to move down, right? When they come into this left ventricle, right? So they can see another opening here. What is the name of this opening? Can anyone tell? What we call as? What is it? What is it? Aorta. Aorta. That is what we call aorta, right? So is aorta also having semilunar valves? Right? Having semilunar valves. Right here, we enter to this one with high pressure. That is why this part is very thicker, because now this is going to push, right? Now this is going to give the pressure, right, to the blood. This want to move all over the body. Nearly 5 liters, 5 liters, we have the blood inside our body. Nearly 5 liters, right? So that 5 liters, right? So in here, little by little, right? For each second, for each milliseconds, okay, within 0.3 seconds, this is happening. Right? The total cycle is 0.8 seconds. I will tell you how that happens. Right now, within that few seconds, quickly, that is the blood is getting entered to the aorta. Right. So that aorta should come out now. Right now, from where it comes out, from this area that is coming out. Right, from that area that is coming out, and that is dividing into 3 branches to top, and the rest of the branches coming down. Right, the rest of the branches coming down like this. Now, that is why in the diagram in the book, you can't see this thing like this. That is a bit different. Is it clear now? Right. Okay. That's how you see the heart. Right. Now, this is the thing we call aorta. So, this is also aorta. Right. Starting aorta, opening of aorta. This is what we call, this is like an arch now. So, we call arch of aorta. What do you call this? Arch of aorta. Right. So, this is the arch. I'm going to trace the one. Arch of aorta. Right. Right. Now these 3 parts, they will go to the top side of the body as subclavian and carotids that you don't want to know. Right. So they are going like that. And here now the entire blood is going all over the body to the top place like this, to the bottom places like this. Right. And the other thing what you must need to know, right? Whatever the thing you are feeding, right? Okay, if you want to help others, you want to be in good health, right? That means you must need to eat properly, right? So what you are doing when you want to eat properly, right? When you want to eat properly, what you are doing? First of all, you have to eat, right? When you want to be healthy, you want to eat properly, right? So heart is also doing the same thing, right? It gives the blood supply from these branches that we call coronary arteries to the heart. Right, to the heart, not like that. That is an example. Like that, that is giving blood from the coronary arteries. That is why some people having heart attacks. Myocardial infarctions we call. Heart attacks. Why? When they eat lot of cholesterols, okay, when they eat lot of lipid things, fatties, cutlet, blah, blah, thing we are eating now. Right? When we eat these kind of things, what is going to happen is actually these arteries, small arteries, no? These are small arteries. So these small arteries we call, right? These we call coronary arteries. These coronary arteries, right? They will get blocked, right? They will get blocked. I will tell you when I tell you about arteries, right? They will start to block, right? When they got blocked, what happens? Now they can't give blood to heart. Now heart is not working. Let that it start work and then finish, right? Suddenly you will face the death. Right, so like that things also happen. Okay, so that is very dangerous. So don't take cholesterol things. Eat good things. Don't take liquid things. Don't eat too much of oily things, fatty cutlet and all. Limit it, right? Otherwise, we'll end up with having cholesterol, right? Or else you have to work out, right? You have to exercise. Right. Now, fine. Now here you see that is happening like that. Fine. Now, what happens actually, right? Now, all the time, this is not happening like this, no. This, like the blood is coming to this one, and then going to this one, and then going to the lungs, and then coming here, and then going to here, and then from the this thing, it is providing to the entire body. One by one, that is not happening. So what happens actually? At once, this will compress like that, and then this will compress like that, right? Then the blood is going all over the body, right? And then both will relax, right? So we call atrial contraction, ventricular contraction, total relaxation. Atrial contraction, ventricular contraction, relaxation. Atrial contraction, ventricular contraction, relaxation. Like that only the heart is working. Now you can see, anyone knows about how the lub-dub sound is coming? Like this. When atrial contracts, right, when this part is contracting, these both valves, what should happen? Bicuspid and tricuspid, they want to open, right? When open and give the blood towards the downside, right? They are giving blood towards downside when I squeeze this one, right? Now this both open, right? Once it go inside, okay, once it go inside, that should close this one, no? Otherwise, what will happen, right? The blood which has gone down will come again back in vain, right? Again, it will come back, right? Therefore, what should happen? The gate should close. So that open like that, they are closing like this. Lub, 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 lub. That is lub, okay, still lub. So when this closed, okay, when bicuspid and tricuspid valves, when they get closed, lub sound is coming. Lub sound. Okay. Now the entire blood gone down, right? Now what is going to happen? From the aorta and the pulmonary artery, from pulmonary artery towards the lungs, from aorta towards the total body. Like that, they are going inside. When the blood is going inside by squeezing these ventricles, right? Contracting this ventricle, ventricular contraction, right? Now this entire blood is going up, right? Okay, then after this become relaxing, what is happening? The blood is going like that, it will come down. It will come down now, right? Therefore, I want to block it. So what I'm doing? I have half moon valves. What do you call? Semilunar valves. I have semilunar valves. Now what happens? Semilunar valves, dup, 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 like that. That is going to be closed, right? So how the lub is formed, right? When the bicuspid valves are closing, lub, right? Then after blood is going here, this will close, this both openings, aortic opening and pulmonary artery opening, right? That both will close by the semilunar valves, right? Then it's called dub, right? So lub is bit longer sound, lub, then dub. Dub is very short sound. That's how you want. Lub, dub, lub, dub, lub, dub. Like that. Fine. Now, this 8, what do you think? Do you think this is getting a lot of times to do this one? No, just few milliseconds, okay? I tell you. Now here, you see, to atrial contraction, to contract this one, this is working, right? Until you die, this is working, okay? For atrial contraction, it is getting only 0.1 seconds, 0.1 seconds for atrial contraction. Then for ventricular contraction, that is getting only 0.3 seconds, right? And to total relaxation, that is happening 0.4 seconds. 0.4 seconds. So altogether, how many seconds for one cycle? 0.8 seconds it takes to complete one single heart cycle. 0.8 seconds. Clear? Right? So within 0.8 seconds, one complete cycle, right? Atrial contraction, ventricular contraction, total relaxation. Okay, this is how you are getting the used blood without oxygen, right? Without oxygen to the heart's right side of the heart. Okay, the total right side of the right side of the heart, you see, total right side of the heart that is having only without oxygen blood. Low amount of oxygen is there, right? I can't tell without because low amount will be there, very low, right? Therefore, that is like blue color. So that blue color is there. Now what happens, right? From this side, that is going into the lungs, So first circulation is happening with the lungs, right? First circulation is happening with the lungs. After that, from lungs, they are coming like this and getting into the left side of the heart. So that they get entered, the blood is coming here, and then they open and comes here, and then they are giving all over the body. So second circulation is giving all over the body. The blood is giving all over the body, right? So that we call as second circulation. So this entire heart cycle process or the heart circulation process is what we call double circulation. Are you clear? What is double circulation now? Right? One circulation is going to the lungs and coming like this, right? Purifying the blood, that means oxygenating blood. And then the next amount of blood is going throughout the body, that we call second circulation, so that we call double circulation. So human, we are having double circulation. You see, when I use this, my hands, and when I use my energy, so each and every part in here, they are using my oxygen. That means, you see, you can see here, right? Okay. So, okay, you can see the veins here, right? So when you see the veins, now it is not coming also, right? When you see the veins here, you can see the blue color or green color, something like that, right? A vein like this. So these are veins actually, right? So these veins carry blood to my heart back again, right? Okay, you can see in here also that when the doctors, when the nurses, they want to drain the blood, right? So what's they are doing? They will get, you see this one, right? So here they will get the blood from the veins, not by the arteries, because arteries having high pressure, but veins having low pressure, right? So veins having the used blood. So when I use my hand like this, now here I use my oxygen, right? After using my oxygen, what happens? The blood is going like that. So that is deoxygenated blood. This blood is going like this, and here comes, and it is getting into my heart from the superior vena cava, right? So from my head, neck, and from my upper part of the body, that is getting into superior vena cava. From my legs and everywhere, stomach and everywhere, right? Now it comes here for the inferior vena cava. They both get joined at this point, we call right atrium. Then it is entering here, then that is going to pulmonary arteries, and that is leading to the lungs. When they go to lungs, right? This is the actual blood circulation. Okay, human circulation means this is what the thing I'm telling now. Okay, right? Now that is going into lungs, right? After going into lungs, what happens? The lung is what is doing here. Millions of alveoli are there. Okay, millions of alveoli are there. So what they are doing, each and every alveoli surrounding them, lot of capillaries are there. They are putting in oxygen inside, getting carbon dioxide back. This is happening always, right? Now in grade 11, that's what we are doing now these days, right? So here, what happens? The oxygenated blood is coming to my heart, and every time to the left side only the oxygenated blood is coming. So with oxygen we call oxygenated blood. Oxygenated blood is coming here, and from the aorta, that is distributing all over the body. From these parts, from the upper part of the body is for my hands and my neck and my brain and everything. From this one to the bottom part of the body for kidneys and legs, stomach, and everywhere. Right? Okay. So this is what we call the main circulation process which happens in the human heart. Is it clear?
Yes.
Is it clear? Right.
Yes, sir.
Okay. I'll tell you after all this thing also. Right. So if I tell you suddenly, can you draw the heart? Still can't, right? Okay. Right. Okay. Now step by step, I will tell you how to draw the heart. Right. Step by step. So you have 4 things now. You have four spaces, right? Okay. Before going to that, right? Now I drew here. Right. I drew here. Now you have an idea about that. Shall we go for a video segment and come? We'll see what is actual heart is. Rehan sir. Rehan sir.
Yeah.
Can we play first and second videos?
Okay.
Okay. Until Rehan sir plays that video, do anyone having any problems regarding this? Anyone cannot understand anything? Is there anyone who can understand my language or anything? No, right? Everyone clear? When it is before ending of the seminar, you will know how to draw the heart without copying anything, right? You see, with logics, you can draw easily, okay? We answer, we can't hear.
The circulatory system comprises blood, blood vessels, and the heart. The heart is the central organ for pumping the blood throughout the body. Heart is made up of strong cardiac muscles. Heart pumps liquid blood, a tissue which transports nutrients, gases, waste, etc. along with it. The right upper atrium receives deoxygenated blood from whole body, which is pumped into right ventricle below, and it sends the blood to lungs for oxygenation via pulmonary artery. After oxygenation, blood travels through pulmonary vein and is received in upper left chamber, that is left atrium, which pumps it into left ventricle below. Then it is pumped into aorta, which is source many arteries which carries oxygenated blood to different parts of body. Arteries get divided into very narrow blood capillaries where exchange of substances takes place. Capillaries forms a web-like network to reach maximum cells. Capillaries join together to form veins. Isn't it a sophisticated system?
Right. Okay, before going to the second video, right, come to the tute quickly. Right. So tute is all about the human circulatory system. Right. Okay, you see, there's a flow chart. In here, what we're going to see, the structure of the human heart that is there. Right. And we have to see the diagram and the main parts of the heart. Now you already know everything. Right. And we need to see. And we have to see about the arteries and then diagrams and functions, veins, the diagrams and functions, capillaries, diagrams and functions, and we have to see what are the things what we can find inside the blood. So what we call components of blood. And then we have blood transfusion. How we can give the blood, how we can gain the blood. And in case if something happened, right, if unmatched blood is going into some other one, so what is going to happen? They will get coagulate and they will get destroyed. So that is also we're going to see in this part, right? And then circulatory system, right? So circulatory system that now in the entire body, in the video also you saw that, right? That is a entire closed system. That is not open, right? That is not open to anywhere. When in case if it is got open, what happens? The blood is going to bleed. Okay, it will start bleed. Right, so this is a closed system. So if you ask to tell what is a circulatory system, what will be your answer? It's a closed system which transports blood throughout the body, right? A closed system which transports what? The blood throughout where? Throughout the body. That is what we call a circulatory system, right? Okay, then what happens? The organ that pumps blood into blood vessels of the circulatory system is known as what? Heart. The organ which is pumping blood into the necessary blood vessels. So these all things are we call commonly, these are blood vessels. That means they are taking blood, right? They're taking blood away. So that is there. So you can see an image there, side heart is there, blood vessel is there. So we'll see furthermore, right? Then structure of the human heart we saw now. Now you know how to draw even. So one step by step I will tell you how to draw that one, right? Then you see the heart having 4 chambers. The upper chambers are called atria, or we call atrium. You can write atria, you underline that one, and then you write with that one atrium. Also we call as auricle. Atrium, we call it always, we call auricle, right? Auricle. So upper chambers we call atria and lower chambers we call ventricles, right? Ventricles. So we have left atrium, left ventricle, right atrium, right ventricle, as I show you, right? There are 2 blood vessels, two valves in between the atria and the ventricles that we call, for the left side that is bicuspid valve, for the right side that is tricuspid valve. You see the tube and go, okay? So I'm seeing the tube and telling. There are 2 main arteries connected to the ventricle. So what are the 2 main arteries connected to ventricle? The main artery which is connected to the right ventricle that we call pulmonary artery. Okay, then the main artery which is connected to the left ventricle that we call aorta. Okay, that is clear now. So aorta is taking oxygenated blood, right? While meanwhile pulmonary artery is taking deoxygenated blood, right? Okay, next one we have there are semilunar valves at the starting points of main artery. So I told entire thing, okay, right? At the starting points, what we have? Semilunar valves. So you can keep in mind. Today the poet I'm telling this, I'm doing this lecture or like the seminar, right? So here you can see. But today it's a full moon poet. So moon that we call in other term lunar, right? And then here we have semi-lunar half, right? So like that, right? Right. Then there are semi-lunar valves at starting point and of the main arteries, right? So aortic semi-lunar valves are there that I told at the starting point of aorta. Then pulmonary semi-lunar valves are there at starting point of pulmonary artery, right? The main veins are connected to the atria. You see, superior vena cava, inferior vena cava comes from here, getting enter from this area. Okay, like that. Then opening from the right atrium, left and right pulmonary veins. You see, left and right pulmonary vein, getting enter to the heart from this side, right? So you must need to know the logic, my dears, right? Each and every single thing when you are studying science, that you can enjoy something. You have to get a knowledge. That is why we are learning, right? Otherwise, just to copy down, and paste a diagram and just to know few facts by heart them, it's in vain. Okay, then you will lose interest in science. Science is something, see, you can do something with that. Okay, otherwise if I don't like science, can I be a doctor in future? Can't, right? Okay, now I'm in the last stage, right? So as a medical student, so I'm in the last stage, 4th year, right? That is because I love science, right? Earlier in your age, I just hate science actually, right? Because I didn't got a teacher like me at that stage. If I got, right, I'll be in next level. Sometimes I might be a scientist, right? So, but you see, you can achieve a lot of things. I hate science until I come to all of us because I didn't study it properly. I didn't know how to study it properly, science, right? But once I come into A levels, I realize science is that interesting. You know? Biology means, right? Each and everything that we can, you see, each and everything has a reason, right? Why this blood is coming from here, why this blood is coming from here, what kind of blood is that, right? From where they get enter, right? Then how they come and how they go to lungs, how they get oxygen. Nice process, okay, right? Then after they getting oxygen, how they come into heart back again, then how they give all over the body. Then for each and every organ, right, when this blood is going, what will happen, right? Where the urine is forming, right? Okay. in the kidneys, right? How nice the structures are there, right? Okay, like that, how the respiration is happening, right? What are the things that should happen to the respiration process? How our digestion is happening, right? Okay, not only that, physics also like that. Each and everything has a logic, right? If I move somewhere, right, why I have to move, how I move, when I push something, like that, right? I'm not going to these things, but right, you must need to know when you ever studying something, you must need to know what you are studying. Otherwise, for the sake of studying, 1 plus 1, 2, 2 plus 2, 3, 2 plus 2, 4, 2 plus 4 plus 4, 8, like that when you study, right? You must need to know what you are studying. Then only that is going into your brain. You have to love what you are studying, right? So for that thing, you want to make it in an interesting way, right? Okay, so then that means you have to know the reasons why you are studying, right? Whenever you are eating, that you know. Whenever you are when you are washing face, you see in mirror, like that, nice, no, like that. Okay, so like that, you are impressing yourself. Like that, in studies also you have to do the same, right? You love watching yourself in front of the mirror. You see, like, more than yesterday, I'm a little bit nice, no, like that. So like that, you want to see the studies as well, right? And I studied something new, right? For one day, if you study one new thing, right? For 30 days, you can study 30 new things, right? Fine. Now come back here. Now you forgot everything, right? Okay, so I told all the things here. So right pulmonary veins, how they comes and all. Before going to arteries, now I'll draw it back again. How to draw with the steps, right? Before that, we'll go into the second video and come and we'll see how to draw this heart by practicing, right? Rehan sir?
Okay.
Your heart is a pump. It's a muscular organ about the size of your fist and is located slightly left of center in your chest. Your heart is divided into the right and left side. The division protects oxygen-rich blood from mixing with oxygen-poor blood. Together, your heart and blood vessels comprise your cardiovascular system, which circulates blood and oxygen around your body. In fact, your heart pumps about 5 quarts of blood every minute, and it beats about 100,000 times in one day. That's about 35 million times in a year. Oxygen-poor blood, blue blood, returns to the heart after circulating through your body. The right side of the heart, composed of the right atrium and ventricle, collects and pumps the blood to the lungs through the pulmonary arteries. The lungs refresh the blood with a new supply of oxygen, making it turn red. Oxygen-rich blood, red blood, then enters the left side of the heart, composed of the left atrium and ventricle, and is pumped through the aorta to the body to supply tissues with oxygen. 4 valves within your heart keep your blood moving the right way. The tricuspid, mitral, pulmonary, and aortic valves work like gates on a fence. They open only one way and only when pushed on. Each valve opens and closes once per heartbeat, or about once every second. A beating heart contracts and relaxes. Contraction is called systole, and relaxing is called diastole. During systole, your ventricles contract, forcing blood into the vessels going to your lungs and body, much like ketchup being forced out of a squeeze bottle. The right ventricle contracts a little bit before the left ventricle does. Your ventricles then relax during diastole and are filled with blood coming from the upper chambers, the left and right atria. Then the cycle starts over again. Your heart is nourished by blood too. Blood vessels called coronary arteries extend over the surface of your heart and branch into smaller capillaries. Here you can see just the network of blood vessels that feed your heart with oxygen-rich blood. Your heart also has electrical wiring, which keeps it beating. Electrical impulses begin high in the right atrium and travel through specialized pathways to the ventricles, delivering the signal to pump. The conduction system keeps your heart beating in a coordinated and normal rhythm, which in turn keeps blood circulating. The continuous exchange of oxygen-rich blood with oxygen-poor blood is what keeps you alive.
Right. Now, in your file, in your tute, right, you have how to draw the heart. That one you see here, you have to draw with me this way, right? First part, what you have to draw, right? Just like this. Just draw like this. First step, right? Draw like that. See properly. First step is that one. Second step, make that into two sides. Right? And then what you have to do? Draw two valves. Right? Here it comes. These all are like similar, but this side is bit thicker. Right? Okay. Now, then you have to name this as what? Septa. Or we call septum. Right? That was septa. Then here you have atrium. So this you know, this is left side. This is right side. Okay. So this is what we call left atrium. And this is what we call right. Tell with me, atrium. And this is what we call left.
Ventricle.
Ventricle. This is what I call right ventricle. Right. Not only that, we have two valves. The left side two valves, what we call
Bicuspid.
bicuspid valves. This one we call tricuspid valves. Right. For the bicuspid valve, we have another name also. I will tell you now. That we call using mitral valve. Mitral valve. Right. So these are the four chambers of the heart with their valves and their parts. Right. Quickly draw this one on the first part. You can remember, right? First of all, draw this one. Use the pencil. Draw this one and divide it into two. Name it septum. Right. Then mark down the valves. Don't take too much of time. Quickly you have to go. Once you're done, tell me. If the shape is different, don't care about that. Right? Little bit differences, that is fine. Not big differences. Little bit fine. Right? And name them. Whenever you draw, name them, and you have to name them right horizontally like this nicely. Not like here, here, there, here. We can't name the diagrams like that. Right? We can take the arrows like that, but we have to name the diagrams like in proper straight line. Okay.
Done, sir.
Done. Right. Okay, next step we'll go. Now for that part, you know how to draw. See? Going like that. Here. Right? What happened? You are into two parts. Here. This valve, here this valve, here this valve, here this valve. Nice. Again. Right. Now, as the next step, what is going to happen? From here, inferior vena cava, and from here, superior vena cava is going to come inside. Both. Both will give blood here. Right? And then what's going to happen? That next step, the blood is coming into here. Then here I can see an opening that we call pulmonary artery. This is what? Superior vena cava. This is inferior
Inferior.
vena cava. Right? Okay. This is having what kind of blood? Deoxygenated blood. Right? So no oxygen. No oxygen means low oxygen. Okay. Little amount. Blood is going like this. Blood is coming like this. Right? And then the blood filled here that is getting into this pulmonary artery, and that is coming out from these areas. Right? So this is what we call pulmonary artery. This is one side, one circulation. Huh? And this is what we call, this is left side, this is right side. So this we call left pulmonary artery, right? And this is what we call right pulmonary artery. Okay, and here we have semilunar valves. Semilunar valve, right? From here, the blood is going towards the lungs. That is clear, no? Right? So this is another single circulation after this thing what happens. Quickly draw it down. So draw it. Once you're done, tell me.
Done, sir.
Done. Right. Okay. Next, what is going to happen? Now, the deoxygenated blood went to the lungs. Right. Now, from lungs, this is coming like this. This is what we call left pulmonary vein. Left pulmonary veins. Right. This is right pulmonary. right, with oxygen blood, right, getting enter from here, here, and here. Now what happens? They are draining blood down here, right? Now what I can see here, the aortic opening is there, aorta, right? This aorta, we have semilunar valve as well, right? Semilunar valve as well, right? Now what we call this one? This is left pulmonary vein, right? And then this is right pulmonary veins, right? Vein and veins both, right? Then this is what we call aorta or aortic opening, right? And here we have semilunar valves. Semilunar valves. Now what happens when the blood is pushing, like squeezing like that? Now what's happening, right? Now from here, start to release the blood like this. Blood is going like this, right? So this is what we call the aortic arch, right? And these are the blood which is going to the top of the body, right? And this is the blood which is going to the bottom of the body, right? So like that they are going. And also I want to tell there are few small arteries that we call coronary artery, right? These things we call coronary arteries. Is it clear? Soon, right? Right now here oxygen is there, here no oxygen. The red color ones. Sometimes when they ask, you just like they will ask, what is that? So you can name it as aorta, inside brackets, aortic arch, so that they know that you know well, right? You know the heart well. That is an arch, that is aortic arch. Okay, when you touch your second rib, you have a rib cage. When you touch your second rib, in that rib area only, right? In back, behind that, only the aortic arch is going. That is the biggest blood vessel in your body. Done?
Done, sir.
Done. Right. So at last, okay, at last I'm going to entire thing. Right. Okay. Quickly name this. Right. Tell me what is this? What is dividing? What is the divider
It's
of heart
septum.
into?
Septum is a
right?
septum.
And here both upper chambers, what we call?
Atrium. Yes, control.
Lower chambers, everyone should answer.
Ventricle.
Lower chambers we call
Ventricle.
ventricle, right? Okay, so what is this side? This is, tell me.
It's the left
Left side.
side. The other one
This-
is the right one.
Right side. So what do you call this one? Left,
The left atrium.
left atrium. This one,
The right atrium.
right atrium. This is
The left ventricle.
left ventricle. This is
Right ventricle.
right ventricle. Everyone should answer. Why this is becoming more thicker on the left atrium side? So left ventricle side.
Because it should pump blood.
Because it should pump the blood all over the body, so it should have a high pressure. So for that, to give that pressure, that's having a thicker wall, right? And we know the thing, right? How the blood is coming from the bottom part of the body using IVC that comes, and here from top part of the body using SVC, the blood is coming, and that both blood is draining to where? Right atrium. From right atrium, the blood is going towards the right ventricle, and here we see the opening. So that is getting into the pulmonary artery opening using the semilunar valve. Right? When it comes to pulmonary artery opening, that is going into the lungs like this, right? Okay. Then it is going into lungs like that. So this we call left pulmonary artery. This is what we call right pulmonary artery. This is what we call SVC. Right? So like that is happening. Right? Fine. Then, okay. Now this is IVC. Right? Inferior vena cava. Then what happens? The oxygenated blood is coming from here, right? Like this. And then from here, it comes like this. Right? They all getting enter into the where? The left atrium. Then what they are doing? They are going through the bicuspid and tricuspid valve into the which way ventricle? Left side ventricle. And here I can see the aortic opening with semilunar valve. So blood is draining into the aortic opening. Now from here, that start to come like this. Right? And the blood is going like that. Right? As the aorta that is going down. Right? So that is what we call aortic opening, and this is what we call aorta. So this is the entire blood draining process or the blood circulation process in the heart, and this is what we call the double circulation. Right? The double circulation. Right? Okay, so this is the entire heart and the entire thing. Draw that up. Now, do you feel, can you name a heart without any help?
Yeah. Yes.
Right, now you can draw as well as you can name, right, without any of these difficulties, right? That is what we call the learning, proper learning, right? Once you're done, tell me.
Done, sir.
Finished. Okay. Good. Fine. I'm erasing. Right. Now you have a proper idea about the heart, right? So just practice, okay? Right. Now in this blood circulation, we'll go to the next step that you have to know about the arteries, veins, arterioles, venules, and blood capillaries. Right. Now, as per my desire, right? Okay. As per my desire. Now this man is watching. Right. Now you see here, this man's heart is this. Nice heart. Right. We have to enjoy the studies, right? Enjoy that. That's all. Okay. Now you know from here what is coming out. What is this? What is this? What is it?
Out.
Aorta. Aorta. I will do a bit big. Okay. Okay, this is not this big, but I will do a bit bigger. I want to show you something. Right. Now this aorta, when it is going down, that is dividing into, now this entire size can't go all over the body. No, it has to be divided, right? Now that is divided into several arterioles. What do you call? Several what?
Arterials.
Arterioles.
Right. Nothing that is going down there, right? Here. It is dividing into several arterioles. Right. Okay. These arterioles, furthermore, dividing into simple structures that we call capillaries. Right. This will join with these everything, right? Like this and this, like this and this, they have joined these combinations. Right. You can also try drawing. Right. Right. So that is coming like that into capillaries. Right. So what is this? Aorta. Right. So these are main arteries. Right. Artery. And these are what we call arterioles. Arterioles. And when it comes to this place, what we call
Capillaries. Capillaries.
capillaries. Right. Now this is actually happening. Right. Now you think like this is here, this one is there. No? So this one's hand. Okay. This one hand. Other four fingers. The main finger. Like that. Right. Main finger. Just think here. His main finger. That is a bit small. No? Little bit big finger. Right. That is his one hand. He went to gym only for that one hand. Finger. Right. Now what happens from his sutang heart? Right. From his sooty heart, that is giving blood like this. The blood is coming like that, coming like that, coming like that, and divides into arteries, and here you see divides like that. Now you think I want to move my finger like this, so I need energy. No, that means I need oxygen. Right. Now this will give oxygen to me. Right. Okay. Now from this area, I'm going to get oxygen. Right. So from this area, what is happening? The oxygen is removing into my muscles, to the cells. Okay. Oxygen is going. So when the oxygen goes, what happens? That becomes deoxygenated blood. Right. Now you see here, this is coming into capillaries of the veins. Right. So like this, they are coming, and they come like this and go into heart, thing like that. Is it clear? Right. So that is what I'm drawing here. From the heart to all over the body, from upside and bottom side, wherever. First of all, that is going into artery, the big tube, the big PVC tube, and that is going into small several PVC tubes according to the places. Okay. So when it is kidney, that is for kidney, and according to the place that is going. right? So like that it is going. Now what's happening after the arteries? What happens that they're converting into arterioles. Arterioles are a bit smaller than that, right? Then they go into the capillaries, right? Now what happens here, right? Here what should happen? Okay, then they are taking the blood like this. Right? You join like this, and they are taking the blood. So these are also capillaries. Right? So in these capillaries, yeah, things like this. Right? So these are capillaries. Until this entire part is we call capillaries. Now when it comes to here, this we call venules. Right? And then these are getting entered into vein. And they go into the IVC. Is it clear? Is it clear how that happens? Right? Okay.
Yes.
So blood is pumping from the heart from here. Right? Pumping from the heart from here. Right? From there. That pumps. And they get entered. Right? They get entered to there. Right? From upper part of the body also, the same thing is happening. Right? So like that only, the blood is moving all over the body. Right? Now, if I want to show you a particular artery inside of the artery, so if I zoom this part, right? If I zoom that part for you, it's like this. Right? That is like that. In here, artery is having a thick wall. Right? They have a thick wall, right? I told you something in the coronary artery, what happens? Actually, when you eat lipids and all, what is going to happen is, right? The lipids and everything comes here and deposits. Depositing like this and this and this and this and this and this and this. Right? Now what's going to happen? This will obstruct the pathway and the empty part is being narrow over like that. Are you clear? Right? That is depositing on in between the walls of the artery. So this is what I call artery, right? So this is the artery, right? That is interrupting or the blocking the wall of the artery. Now this small passage now to go to blood. Now blood can't go well properly. Now what happens? The heart will get weak, and heart will die. Right? So this is what we call the artery. Arterial wall is a little bit thicker, right? And but at the same time, that is elasticity also there, right? Elasticity also there. Because of the heart is pumping the blood in high blood pressure with a blood pressure of 120 mg. Okay, Mama Hg actually, not mg. Mama Hg, that means millimeter mercury. 120 millimeter mercury or mercury millimeters in that pressure, right? The blood is pressuring here, right? Into the blood, into the aorta. That is what we call high blood pressure. So sorry, the blood pressure, right? Not high blood pressure, blood pressure. Right? Now here we have the artery. Okay, artery, and the wall is thicker. Right? And then here this is a disease condition. Okay, this is a disease condition. Now if not, nicely, wall is there. Right? And they don't have valves. I will tell you what are valves. Right? So here, blood can come in, go out. Right? That is what you call artery. When I draw a vein for you, right? This you think this is your leg. Right? This is your leg. Right? That is your leg here. Right? And what you have to do is, right? What you have to do is, now when the blood is coming down, the blood should go up, no? After using, right? The blood to come it, that is very easy. That it will come. Right? Okay, when they come, you see, they are forming this capillary all over the area as a capillary network actually. Right? So these capillaries are there like this. Right? These arteries are coming, they form the capillary. And then what happens? This blood should go like this by making the capillary network. Right? Now this is going like this. Now I will zoom it, okay? This is not this big. I will zoom it and show you. Okay, now I zoom this one. Right? Now you see here, if it was like this, the vein was like that, right? Veins having several structures, actually the valves, right? Actually the valves like this, like we had tricuspid and bicuspid valves, no? Like this, they have valves. Why? When they go up, right? Because now you see here, heart is pressuring the blood. Heart can pressure the blood to go all over the body. But from our leg, the blood, if it wants to come up, if the blood wants to come up, there's no any pressure. Okay, there's no any pressure. So what happens? When you walk only, the blood is coming up, right? When you stood for a long time, that is why you feel numbness and all, right? There's another thing, right? So you have to walk, then only your muscles are working. When muscles are working, what happens? These veins are being constricted, like then only the blood is going up. Okay, these valves are getting open like this, right? These valves are getting open like this, the blood is going up, right? These valves are getting open like this, then blood is going up. If they are not going, they will get closed. Are you clear? Right? So you have to walk. Otherwise, what is happening? These veins will start to appear on your leg like snakes, right? So some people, you see, you go and search varicose veins. Okay, varicose vein means the people who are not walking or doing the things or do not work hard. What's happening when they keep the leg gas like in one place like that for a long time? The veins will start to come because the blood is not going to the heart, right? That will make you to a disease condition we call edema. We call pulmonary edema conditions and all will come, right? So what happens? The blood is not coming back, so heart will again stop, right? So these kind of things are there. So we have to keep walking, right? So for that purpose, what they have valves, veins having valves, but they don't want, they are automatically, however, the blood is pressuring, right? Here they don't have a pressure, so that they have to have a valve, right? Just by hearting, veins having valves, vein having valve, vein having valve, vein having valve, vein having valve, right? Okay, but logically now you know, when they want to go up, then without the blood is coming down, the valves are getting closed. Now when the blood which goes up, they will stuck. That means little by little they will go up. They will not come down. Because of that, they have valves. Is it clear? Is it clear? Right? So arteries, no valves. Are you clear?
Yes, sir.
Yes, sir.
Is it boring?
Yes, sir.
I sleep. Boring?
No,
Sleepy?
Yeah, sir, clear.
Yeah, boring. Huh?
No, sir.
No, sir.
Right. So these having valves. Right? Valves? Yes. Right? These are thicker. Thick. Elastic. This is what? Thin and elastic as well. Right? They are also elastic. Right? And here blood flows with high pressure. In arteries, right? blood flow is high pressure. You see the tube also, high pressure. Here, blood flows with low pressure. Low pressure in the veins, low pressure. Right? Okay. And here what they call? Arteries are ending with what? Arteries are ending with arterioles and what you call finally? Capillaries, right? Ending with capillaries. Ending with capillaries. Veins are starting with capillaries. Is it clear now? Veins are starting with capillaries. You see here, they get oxygen down and then carbon dioxide is moving inside the blood vessels and that is being completed, right? That is why we require aorta, then artery, then arterioles. So according to the places for like these kind of structures, capillaries and all, millions of them are there, right? Okay, for my hand, for each of my finger, even you see how many capillary networks are there. In kidney, there are a lot, right? So like that, in the entire body, we have a lot of things, right? So that is how when they release oxygen, they automatically becomes veins, right? Okay, when they're releasing oxygen, that means when they won't release oxygen, that means oxygen has been used. That means energy has been produced, right? So these are the features of these arteries, and these are the features of the veins, right? They have no valves. They are thick. They are elastic, high pressure, and capillaries. These are thin and elastic, having valves to what? Right? When the blood is going up, they don't want to come down, right? Okay, then functions also I will tell you the same time. Arteries function is what? Moving away, blood away from the heart, moving blood away from the heart. One of you asked me, sir, don't change the voice, right? Why is that? This is like irritating. Fine, okay. So here I just want to check whether you are sleeping or not. That's why. Right? Sometimes I change my voice because I want to check whether you are still alive. That means in live in the program. Right? Now here you see always the arteries, what they are doing? Always arteries, they are taking blood away from the heart. Right? Always arteries. Why? Pulmonary arteries included. They are also taking blood away from the heart. Right? Okay, taking blood away from the heart, that is arteries. But the only artery which we have the deoxygenated blood, right, for your knowledge, that is what we call pulmonary artery, that is carrying deoxygenated blood. All arteries, right, generally I can tell all arteries carrying oxygenated blood with oxygen blood to all entire body, right? So that is carrying blood away from the heart, moves away from the heart. Arteries itself, they are moving away from the heart, right? Then what they are doing, they are distributing blood, okay, to the body organs, right? Then veins are what? So arteries means what then? Arteries means the blood vessels that take the blood away from the heart, that we call arteries, okay? The blood vessels that take blood away from the heart, that we call arteries. Next come veins, I told you now, the blood vessels that take the blood towards the heart, take the blood towards the heart, that we call veins, right? If you don't understand any part, please ask me. Features, walls are thin, valves are there, present, blood flow with low pressure, and veins start with blood capillaries, right? Now, what can you see about the functions here, right? Veins are move towards the heart. Veins move towards the heart. Veins move blood towards the heart, right? And then what they are doing? Now, arteries are distributing blood to the organs. Now, here veins are collecting blood from the organs, collecting blood from the organs. Are you clear? Is it clear?
Yes,
Clear? Okay. Right? Okay. Tuti, listen me, don't sleep. Tuti, here, sleep. Right? So here capillaries are there. Right? So that is the smallest of blood vessels. You see the tube, the smallest of blood vessels that forms a network. You see, like a kind of network between the arterioles and venules. This is arteriole, this is venule, these are venules. So in between that, they form a network. So what we call the smallest blood vessels that forms a network between arterioles and venules, that we call capillaries. Is it clear? Right? So whenever you write a definition, you just break down into pieces and one by one, you put into your mind the keywords, right? Smallest blood vessels, network, right? Underline those things. Smallest blood vessels, network, Then between arteries and arterioles and veins. That is what called capillaries, right? Okay, you can highlight them. Features: walls of capillaries consist of a single cell layer, right? Okay, here this is very thin, no? They are enough with single cell layer, right? Very thin, no? Enough with single cell layer, and these are the smallest blood vessels. Smallest blood vessels. So there is a feature. What is the function? They can connect arteries and veins. They are connecting what? Capillaries connecting arteries and veins, connecting people, right? Worst, but worst signals are there, right? Connecting arteries and veins. Next one, take care of diffusion of gases, nutrients from the blood cells to the body. That I told, right? Now, what happens? They are releasing oxygen, they are releasing hormone, they are releasing nutrients, right? Same time, what happens? They are gaining carbon dioxide, right? They are gaining carbon dioxide and they are letting it out of the body, right? You see, what is photosynthesis? You know, right? Photosynthesis. Using carbon dioxide and water, they are creating glucose and oxygen, right? Glucose and oxygen to our necessity, right? In the presence of light energy. That means what they are doing? They are absorbing energy, water and carbon dioxide, converting into oxygen and glucose. Now we are inhaling that oxygen, we are eating that glucose, they both go into our blood, right? They both go into our blood, right? Now what is happening? Now what is happening? After they go into our blood, opposite reaction of photosynthesis is happening in my blood, right? Whenever I require energy, what is doing? The oxygen which I inhale with my glucose, they both are joining and they release energy. Earlier what happened? They absorb energy to make oxygen and glucose. Now from glucose and oxygen, I release energy to my body to work, and then that is converting into, like earlier they got carbon dioxide and water. Now this is converting into carbon dioxide and water, right? The total opposite reaction, right? So that is what doing. So diffusion means, right, from like blood high concentrated area. So oxygen is there in high concentration in the arteries, high concentration, very pure, go dark, right? So that amount is there, right? So from that amount, right, high concentration to low concentration, they can go. That is what we call the diffusion, right? So they are diffusing not only oxygen, not only carbon dioxide, other gases as well as some other nutrients also, right? Function of the capillary. The other one is take away waste products into cells of the blood capillaries, right? Take away waste products in the cells to the blood capillaries, right? Now what they are doing in the capillaries, they will get all the waste products into the capillaries and they will take into the kidney. Kidney will start to filter, and then using the urine, everything will be going, right? So when you come to grade 11, we will discuss these things, right? So next week, we're going to start that. Right, so you know about arteries, you know about veins, you know about capillaries. Is it all clear?
Yes, sir, clear.
Yes.
Yeah. Do you have any questions? No.
Yes, sir.
Right, clear. Right. So how blood circulation takes place, come to that part also, I told you now. Blood comes into the right atrium from the body, then moves into the right ventricle, right? And is pushed to the pulmonary arteries in the lungs, right? Then after picking up oxygen from the lungs you write somewhere there nearby. After picking up oxygen, inside brackets, from lungs through alveoli, if you want, you can write, right? Close the bracket. And then next point, the blood travels back to the heart, right? Again, that comes. So that is a first circulation, right? Okay. Then through the pulmonary veins into the left atrium, right? And to the left ventricle, right? That comes. The blood is coming into the heart. Then they are moving. The blood is going to the entire body through the aorta. So entire body tissues through the aorta. So that is what happens in briefly, but I told you the entire process, okay? Right, so here another mentioned diagram is there here, you can see. So let us go step by step the heart that you already drew, right? So before going to the components of the blood and their functions, we'll go to the next video, right? Okay, Rehan sir?
Yeah.
Third one will go. Right. You saw the entire thing, entire video clip about this one. Priyansa will go to the fourth video as well.
The vascular system is made up of arteries, arterioles, capillaries, venules, and veins. This system can be thought of as a transportation or highway system. These roads provide unhindered flow of life-sustaining fluid and also rid waste from the body. Arteries, which always pump blood away from the heart, and veins, which always return blood to the heart, are similar in that they provide the roadways. Like roadways have different speed limits, weight limits, and traffic to deal with, the vascular system also has its own set of conditions to deal with. Arteries are like freeways offering fast, one-way traffic moving away from the heart. Arterioles act like off-ramps from the arteries to the capillary beds. Capillaries are like neighborhood roads. This is where the loading of nutrients to the cell and unloading of waste from the cell occurs. Venules act like on-ramps from the capillary beds to the veins. Veins are also like freeways, but since they contain 60% of the total blood volume, it's more like slow-moving heavy traffic leading back to the heart. Arteries and veins are each made up of 3 tunics, or coats. The outside layer, tunica externa, the inside layer, tunica intima, and the middle layer, tunica media. In this video, I will only talk about the tunica media. The tunica media is the middle layer of the blood vessel. It is the muscle layer that allows for the vessel to constrict. It also contains elastin, which allows the vessel to stretch and rebound like a rubber band. In the arteries, the tunica media is much thicker due to the forces generated by the heart. So when your blood pressure elevates in response to the demand of the body, the increase in pressure and volume can be tolerated. Otherwise, the arteries would just pop like an overfilled water balloon. Because there's no pulsating forces in the vein, there's no need for as much elastin or muscle in them. Hence, the tunica media is much thinner in veins. More about arteries. Remember, arteries carry blood away and both begin with the letter A. If you've ever felt a pulse, that is an artery. Only arteries pulsate. When you get your blood pressure checked, they are listening for the sound of the blood flowing through an artery. Because arteries are pressurized, if it is cut, a person could bleed out very quickly. Therefore, arteries need to be more protected and situated deeper in the body. When a blood vessel is cut, it is easy to tell if it was an artery or vein. Arteries will spurt pulsating blood, as compared to a vein where the blood just flows. Now moving on to veins. Veins are generally visible just below the skin. One reason for that is to regulate body temperature. Another special feature found in veins are valves. Proof that veins have valves can be seen in those people who have those nice large veins in their arms or hands. You can actually see the valve working by occluding the blood flow, then milking the blood out while keeping the vein occluded. Where the blood stops, that's where the valve is. Now when you let go of the occluded vessel, you will see blood return. One way to tell the difference between a vein and an artery is if you can see the blood vessel, it's most likely a vein. If you can feel the blood vessel pulsate, it's an artery. So what's the importance of having valves in your veins? Let's look at someone sleeping. The body's laying flat, blood flows back to the heart evenly, and you can see there's not much need for those valves. Now let's remove those valves, and you'll see the blood continues to flow. So why do we need these valves? First, let's look at a container of water laying flat, and if you stand it upright, the fluid will fall to the bottom due to gravity. The same thing would happen in the body if we didn't have these valves. Without those valves, blood will flow in the direction of gravity, meaning that when you stand upright, the blood will all pool in your lower legs. Not only would that make it harder to walk, but there's a bigger issue. Now that the fluid has drained from the veins will collapse on themselves, meaning no blood is returning to the heart, and without blood flow, the heart can't beat. In fact, all organs rely on continuous blood flow. Without that continuous blood flow, death follows. Now that we know why we need these valves, let's put them back and bring life back. In closing, the vascular system is just a transportation network of tunnels throughout the body.
Right. So you saw what happens there. Right. Okay. Someone asked me that whether varicose can be cured. Yeah, it can be cured. If you have proper medications, it can be cured. Right. Now we're going to take the blood. So when I take a small portion of blood, right, for the valve like this, right, a test tube goes like small test tube like this, right. So if I have some blood there, right, what is the color of the blood? Blood is in red color, right? Blood is in red color, entire red color, right? Now what happens? There's a machine called centrifuge machine, and there's some procedures. When we put into that is rotating very high speed, very speed, right? So in a high speed that is rotating. So what happens there, right? That is separating the blood. Okay, that is separate. So red is always blood color. So blood is always red color. Then how it is separating? Yeah, that can be separated, right? So if I separated the blood, right, by putting the centrifuge machine, right, that is separating the blood as to two pieces. One is with the blood cell part that we call corpuscles, right? That is nearly like 45% of the total blood that I took out, right? And then I have here as the plasma, right? So here the plasma is there that I have nearly like 55%, right? So out of this 100%, I have 55% is the plasma, right? plasma. Then the next, this we call corpuscles. That means the blood cells actually, blood cells part. Called corpuscles. Corpuscles, right? So actually, when I want to divide the blood, right? So when I want to divide the blood here like that. Right? When I want to divide the blood like that, here, blood. Blood I can divide into two pieces. One is as plasma, and as plasma. The other one as the corpuscles. Corpuscles, right? Corpuscles and plasma. Corpuscles means the cell part, right? So here corpuscles I have 45%, and the corpuscles I can divide they as RBC, that we call red blood cells, and we have what we have next?
White blood cell.
WBC, that we call white blood cells, and we have here platelets, right? Platelets are there, right? Platelets, right? In RBC, their lifespan is actually like 120 days only. So blood cells only 120 days. Yeah, they form in the bone marrow. You know what is bone, right? Okay, when you have a bone like this, right? You are eating bone, right? So when you cut this part, right? When you cut this part and see, you can see nicely the inside of the bone, right? So inside you see here some red color tuberous like that things are there, right? That thing is what we call here in the middle after this thing, right? The tuberous area that we call the bone marrow, right? In the bone marrow only these blood cells are originating. Okay, they are forming there, right? So at the end of 120 days they're going to die, right? So they are forming in the bone marrows. So red blood cells are there. Actually, they are like peppermints, very small peppermints. They don't have nucleus, they don't have mitochondria, right? For the upside view, this is like this, a peppermint, but for side view, it is like this, a dumbbell, right? You see peppermints like this. For side view, it is like a dumbbell. WBC, we have 5 types actually, right? There are 5 types. Okay, actually, they are also dividing into 2 parts. Finally, with granules, that we call granulated, right? And without granules, non-granulated, right? Non-granulated is there. So granulated, you see the tube also, right? So here, white blood cells, actually, granules with granules, there are 3 types, what we call neutrophils. Then we have eosinophils, right? These are cell types, and then we have basophils. Okay, when you come to grade 11, I will tell you all of these structures, right? Non-granulated, we have monocyte and we have lymphocyte, right? Lymphocytes. So also the lymphocytes, we can call them as plasma cells. If you want to note down, quickly note down, right? White blood cells, I also call it as erythrocytes. WBC, I call it as leukocytes. Okay, erythrocytes and leukocytes, right? Platelets are actually, they are like not cells, they are not like cells, but they are like fragments, right? Small cell parts, right? So these helps in blood clotting actually. Okay, when vitamin K is there, vitamin K for clotting, vitamin K is there in the presence of vitamin K and fibrinogen and everything with several helps. What's happening? Blood clotting. I will tell you what is blood clotting, right? Blood clotting means when you're bleeding, now if it keeps bleeding, you only have 5 liters of blood. Okay, so when all the blood is going away, what is happening? You're going to die, right? So without doing that thing, what is happening? The platelets will come to that wounded place, and the platelets, right, with usage of that fibers, right? So in the blood, normally in the blood you can't see fibers, but when it is near to the clot, right? When it's forming clots, we can see the appearance of fibers there, right? So fibers, okay, they are putting fibers, and they will create a mess, right? And the wound here, right? So if this is your leg, right? And where there's your wound, right? Here a wound is there. Now what happens? The platelets will come to that place and they will create a mess like this, so that the blood will not go out, right? So in blood clotting, the platelets are helping, right? Platelets, that is required. When in dengue conditions, right? In virus conditions, what happens? Suddenly the platelet count is going down, right? Okay, so when the platelet count is going down, it is very dangerous. If you got wound or anything like bleeding, you are dead, right? So have to be more careful, right? And the other thing, this WBC is the right protector of our body. Okay, normally we can see the WBC like in 1 cubic millimeter, it's like 4,000 to 11,000 cells only there. But these are the protectors, especially plasma cells. The other also same, right? Plasma cells, what happens, right? When an antigen comes, antigen means the microbacteria or something. When something like this comes, plasma cell is going nearby, like that, right? That is going nearby. These plasma cells, right? They are creating the opposite of that, antibody. Now antigen came, antigen or pathogen we call, right? The plasma cell is creating what? Antibody. Not uncle body, the antibody, right? They are creating antibody and they form the antibody antigen complex tachyblast. Like when a bacteria or virus or something comes, when your immunity is very good. Immunity very good means these are working properly, right? When your immunity is very good, right? So that is forming antibody antigen complex. Finish tachyblast. The bacteria is tachyblast, right? So without you having a lot of virus things, right? Viral things. Even when virus fever comes, you don't want to take medicines. You don't want to take amoxicillin, cloxicillin, antibiotics, right? By viral fevers automatically getting cured with our immunity power. The help of this, right? With the bloods, right? So therefore, within 1 week, you will automatically get cured. But the thing you have to know, you have to get is you have to take rest. Otherwise, what is happening? The entire energy is going to other works, not to produce these things, right? So when you want to get healed, you need rest. Then automatically everything will be okay, right? So in Corona also, what is happening? COVID, right? They are asking to get rest, right? Now here, antibody antigen complex tachyblast, finish, right? So like that, they can do. And neutrophils, what they are doing? When the antigen comes, they are swallowing that. Right? So they are destroying by swallowing, right? So it is like an amoeba. So antigen is coming like this. What they are doing? They are forming fake legs like these structures, right? Fake legs like structures like this. And little by little, like that, they are getting the antigen inside this one. And little by little, they are eating. Finished. That is neutrophils and all, monocytes and all, right? So these kind of things are happening. When you have an allergic reaction in your skin or somewhere, the basophils comes into the field, attack, right? Like that, several things are there. You must need to study, right? So platelets for blood clotting. The here granulates are non-granulated. That is you can study in grade 11, right? So neutrophils, basophils are there. Monocyte, lymphocytes are there, right? And RBC, what they are doing? What they can do actually, right? What they can do actually is, that is the main thing. Who's carrying oxygen? Oxygen is carried by the red blood cells mainly. Okay. So oxygen carried by the red blood cells mainly. So that you must need to know. Okay. Right. So here, oxygen is carried by the red blood cells. Right. Not only that, the other nutrients, proteins, hormones and everything, they are being carried by the plasma. The plasma, the highest concentration is with water. Plasma means more of that is what? Water. Is it clear? Right? More of the plasma is water. Right? The others are as normal shape. Okay? Others are there. Right? Fine. Now, more of that is water, and the gases like oxygen and all, hormones are there, then nutrients are there. What we are eating? Glucose. The entire thing what we are eating, they will convert into glucose, fructose, galactose, and then amino acids, and these kind of things are there. When you come to grade 11, grade 10, we will study, right? So these kind of things getting absorbed into the blood, right? These are also transporting. So blood's main activity or the function is transporting oxygen, especially, right? Okay, so they are traveling oxygen. They are transporting oxygen carbon dioxide, right? And all. Okay, that we call carboxy hemoglobin. And they have, especially they have hemoglobin, a protein called hemoglobin. Hemoglobin is a protein. Okay, hemoglobin protein is there, so they are carrying red blood cells to the red blood cells, right? Okay, so we were studying about the heart circulation, inside the blood is going. So this is what blood is composed of. Okay, so the other way, plasma is having what? Things which soluble in water, things which do not soluble in water, right? Like that. So here plasma, mainly we have water, right? And things soluble in water. You can see nicely, right? Things soluble in water, right? Then things do not soluble, or we call insoluble. Insoluble in water, in H2O. Things insoluble in water. Tell me some examples for that. Things which are soluble in water. Salt.
Salt.
Sodium chloride. Okay, eating salt. Okay, eating salt. Sodium chloride, right? Some ions are there. Calcium ions, sodium, right? We studied now in chemistry part. Okay, we have already studied that part. So ions, you know, sodium is there, potassium is there, calcium, right? Chlorine, blah blah. Lot of ions are there. So they are soluble in water. But there are some things which are not so insoluble in water as well. But the gases, they slightly soluble. Okay, oxygen gas is slightly soluble in water. Carbon dioxide gas is slightly soluble in water. So commonly we call gases, right? Gases are insoluble in water. That means slightly soluble. Okay. Now plasma having a job. What is it? They are carrying hormones. You see this thing. Come to the tube. Right. So 45% of volume in solid form. So corpuscles are in solid form. Cells, no solids. Plasma in 55% is there. So that is in liquid form. So you see cells, red blood cells, and I further explained here with the flow chart. The three types of corpuscles: red blood cells, white blood cells, platelets are there. Then come to the next one. Function of the blood. Red blood cells, I told you, it contains red color pigment, which is called hemoglobin. That's what we have, oxygenated blood, red color. Then functions, hemoglobin carries oxygen from lungs to the body cells and also gives blood its red color. Okay, hemoglobin is a protein. White blood cells, you see, it is categorized into neutrophils, as I told, eosinophils, basophils, then monocytes and lymphocytes that we call plasma cells, right? They defend what? It defends the body by destroying pathogens, or we call antigen or pathogen, right? And producing antibodies. So, chakablas. Next one, platelets, what they are doing. Some virus infection causes a rapid decline of platelet, as I told, percentage, dengue, leptospirosis, right? So when I got a virus fever also, I use like, it is like normally the value is like in between 200 to 400,000. 200 to 400,000. That means 200,000 to 400,000. Okay. That means 2 lakhs to 4 lakhs, that in between that amount, right? So that is a normal value, right? With the dengue people, what happens? Suddenly they are dropping down to 10,000 like that also. Just 10,000. Clear, right? For my one also, once it's got dropped down in 28,000, something like that, right? The viral fever. So like these things happening in the viral fever. So leptospirosis, dengue conditions, this is happening. It helps in blood clotting process of blood and bleeding sites, right? Now you have huge knowledge about this, okay? Plasma, the liquid part of the body, that is known as the plasma. It transports substances dissolved in it. Example, hormones, proteins, enzymes, gases, minerals, vitamins, anything, etc. Right? Okay, highlight them and keep. Right. So is it all clear about the blood components? Are you clear?
Yes.
Yes, sir.
Yes, sir.
Are you
Yes,
sleepy?
sir.
Boring? Boring? No?
No. No.
Little
No.
Boring, yes?
Not boring.
Not boring. Okay, fine. Okay, thank you. Fine. Right. Okay, thank you. One has commented for me that your drawing is superb. Like that. Fine. Right. So now that part is fine. Now we'll go to the final topic of the seminar. Right. That is blood transfusion. Right. If you ever feel to give blood, so if you are more than 18 years, you can give blood, you can donate blood, right? But if you are a donor, you have several criteria to fulfill, right? That you should be in a good health, okay? You should be underweight, right? If you are a donor, right? When you want to give blood, practically we'll discuss, right? Okay, when we want to give blood, so you should be a good healthy one with proper weight, right? And without free of tattoos and all, right? When you have tattoos, you can't blood transfer, like donate the blood, right? Okay, so like these conditions are there, right? So better to avoid these things and all. So you can help others, right, with your blood, right? So that you can give several kinds of bloods, right? So you see here, so blood transfusion, what we're going to discuss now, right? Right, and I want to answer one thing. Yeah, this is the way of doing the class in this normal theory classes as well, right? Okay, this is a normal with the video segments going like this and telling like this. Like even this is a seminar or something like that. This is normal way I'm interacting with you all, right? Okay, no any speciality. Maybe the seminar the same thing. I have to give is I have to give, right? So blood transfusion, right? What is blood transfusion? You see in the tube, the transfer of blood. The transfer of blood from one individual, right? From one individual. Individual means from one person. Okay? From one person. So from one person to another one, known as what? Blood transfusion, right? So transferring blood from one to another, that we call blood transfusion. Simple definitions, right? You have to. You don't want to buy hard, right? So that's why we have divided and gave you. So the transfer of blood from one individual to another one, known as blood transfusion. Right? See, the person who donates the blood called the donor, right? So the person who receives the blood we call recipient. So that we know, right? When we take something, we will have a receipt, right? When you do go for a bank or any purpose, we will have a receipt, right? So receipt means, right, who's the receiver, that he will have a receipt. So that we call receiver or recipient actually, right? Who's donating, we call donor. Who's getting, we call recipient. Why we require to give this blood and all, right? Why we require? Because if anyone got accident, made an accident, right? So he's only having 5 liters, right? So if he's bleeding, right? I will tell you some small thing. Whenever you see some bleeding person, right? Okay, best thing is to give, right? Because he's bleeding, that he lost too much of blood. Sometimes he will be unconscious and he will die. So if you have like, no, king coconut, kurumba, that kurumba water, that is good for them, right? Quickly, that when you, okay, when you give, that is nearly like blood composition, right? Not blood cell, no blood cells, but it is nearly like blood composition. So that helps, right, to get recover from that unconsciousness, right? Sometimes. So in that time, and suddenly when you meet something like that, you can help them, right? Okay, don't just accident, no? Don't go away. Whenever you can help, you just help without going into any trouble. Okay, right. So what I want to tell is, so in these conditions, we might happen to give blood, right? Okay. So when we want to give blood, we have 4 types of bloods. That we have A blood, B blood, AB blood, and O blood. Right? Okay. O is the kind of who likes to give, that kind of people. O, right? Okay. And here O positive or negative also there. Right? O positive or negative also there. That you want to think. Right? O positive or negative also there. That you will see. Now these are the 4 types of bloods what we have. Right? For the donor as well as the receiver. But you see, if I am A, I'm O positive, right? If I am A, I can give only to A. Right? I can give only to A. If I am B, okay, sorry, I can give A and AB as well. Right? A and AB only. If I am B, I can give to B and AB only. Right? Okay. Then if I am AB, okay, I can't give anyone. I can give only to AB. Right? Okay, if I am O, I can give anyone. Right? I can give anyone. So O is a donor which can give to everyone, to the universe. that we call universal donor. What do you call? Universal donor. So if someone is having O, that we call, he is a universal donor. Right? Okay. By the way, you see AB for O, anyone can give. So AB can receive from O, AB can receive from AB, AB can receive from A, AB can receive from AB. Right? So he is a universal recipient. He's a universal recipient. You come here for transfusion takes place. We want to see the compatibility of blood group. Now, as I told you now, right? Okay, as I told you now, right? And the compatibility of rhesus factor. I will tell you rhesus factor. When you come to A levels, you will study furthermore what are the antigens there, what are the antibodies there. So like that, separately you will study nicely, right? So here between the come to the 11th page, compatibility of blood group. There are 4 blood groups depending on the protein component in the blood, as I told, antigen and antibody, these things, right? So group A, B, AB, and O is there. Compatibility you see here, right? If I am the donor, right? If I am the donor, if I am the donor, right? So I might have the blood groups like A, B, AB, and O. I will have, right? So here these are my blood groups, right? Okay, this is my blood type, right? For this side also it can be happen like this, right? Here also recipient A, B, AB, and O, who's going to get the blood. So this we call, this area we call recipients. Recipients, right? Recipients. So that entire thing, huh? Right. Right. Is being met. Right. Okay. So donating and recipient means receiving. So I will do like this. Recipient receiving. Right. From this hand, he is donating. Right. He's a donor. Right. Okay. Now you see here. See here. I'm the donor. If I have A, I can give to A. If I have A, the donor, if I have A, I can give to A. I can't give to B. I can give to AB, but I can't give to O. Okay. Next line. If I have B, I can't give to A. I can give to B people. Yes. B, yeah, AB can know everyone. Right, then B here can't give to O. If I am AB, I can give only to ABs. Can't give. But if I am O, I am a good one. How? I can give to this one, I can give to this one, I can give to this one, and I can give to this one as well. Right? So this is how we are giving the blood. Right? But you see, there's another something called rhesus factor. Rhesus factor. Right? Rhesus factor means that we call O positive. I have O positive. No, you have O negative. I have A plus. You have B minus. So like that we are telling now. Right? Okay. So B minus, A positives, A like things are there. Right? Plus are there, negatives are there. Right? So what the thing I will tell you is negative ones can give to anyone, especially O. Right? Negative people can give to positive people. Right? Okay. Don't take this into life, but negative people can give to positive people, the relevant ones, like this. Like this. Okay. Like this, we have like A positive bloods are there, A negative bloods are there, right? Then B positive are there, B negative is there, and then AB positive is there. AB negative is there, right? Okay, you see, positive people can only give to positive like this, right? If these are plus, they can only give to plus bloods only. They can only give to plus bloods only, right? But negative is there. If negative is there, they can give to negatives as well as for positives. Are you clear? Are you clear? But positive can't give to negative. Positive can't give to negative. That is common.
Vector of protein.
Sorry?
Is that
Yeah,
rhesus
kind
vector?
of. It's a chemical kind of protein. Okay? It's a chemical. So if it is present, if the rhesus factor is present, okay, we are telling that blood has positive blood. If rhesus factor is not present, like for example, if you see the red RBC is like this, now this is not the real thing, right? If rhesus factor is there, it is like this. Okay, the rhesus factor, like a part, right? If rhesus factor is there, huh?
Is it
Yeah, this part
important?
is important. Yeah, this part is important. In your syllabus, that is there. Rhesus factor part is there. If rhesus factor is there, this is much important, right? Okay, otherwise we can die. That agglutation I will tell you next one, right? So if rhesus factor is there, that we call positive blood, right? Positive blood, right? If rhesus factor is not there, no problem. When this is there, right? Okay, I can't give to a negative one. If I give to a negative one, right? The negative ones will have in their blood, right? In their blood, they will have a design like this. Now what happens? You know, when the same kind of designs, when they join with each other, they will chakablast, right? Okay, therefore positives we can't give to the negative ones, right? Actually negatives, they don't have one, right? So we can't give. But for negatives, we can give them. Actually two things are there we have to consider, but still small to understand that kind of thing. That is big, right? But one thing you want to know, negatives always can give. Negative always can give to positives, right? According to this table only, negatives can give to positive, but positives can't give to negative. Are you clear?
Yes, sir. So negatives have an antibody, right? And positives have antigens.
Yeah, both are present, right? When it comes to A levels only, I can. When it comes to the more grades only, I can explain it further. That is big part, right? Okay, right. Now you see here. If you want, you can go through several YouTube videos are there, right? And Google and several books are there, right? So negative bloods we can give to anyone. So A minus we can give to A positive as well as for A negatives. B minus we can give to B positive as well as for B negatives. But B minus we can give, okay. But according to this table only, everything is happening, right? The only difference is negatives can give to negatives as well as for positives. But positives can't give to negatives. Positives can mean only to positives. Is it clear? Right? That means the actual universal donor is or positive or negative. Actual universal donor is or negative. This is the actual universal donor. Who is the actual universal recipient? Universal recipient. AB positive, right? Universal recipient, right? That is actually AB positive. AB positive is the real actual universal recipient, and O negative is the, so this is what we call universal donor. The actual universal donor is O negative. Is it clear?
Yeah.
Right. Okay. The actual universal donor is O negative. So negative can give to anyone. Positive can give only to positives. Are you clear now? This is the rhesus factor thing, right? Okay. Hope that is clear. Fine. Right. So see, represent of positive compatibility of blood group and represent lack of compatibility of blood group. Blood group AB can receive blood from other blood groups, as I told now. Okay. AB is called universal recipient, right? For exam, if you ask to write, just write AB, right? If they ask with the rhesus factor, you write AB positive, right? Normally you can write O is the universal donor, right? Because normally also that is universal donor, right? With the proper one, which can give anyone, that means one. They won't ask like that. If they ask, you answer. Clear? Right? So normally in your syllabus that is there, as O is the universal donor, AB is the universal recipient. That's enough. Fine? Right? Okay. The compatibility refers to rhesus factor I explained you. Rhesus factor is present one of the blood is considered as RH positive. So rhesus factor, this means RH, capital R symbol H, that we call RH plus. Right? And then if they don't have that one, RH minus. Okay. If the rhesus factor is absent in one's blood, that we call RH negative. Right? This is becoming a problem in the when RH positive man marries with a RH negative woman. That is becoming a big problem. RH negative woman and RH positive man. Right? So when the baby is forming, for the first baby that is fine, for the second baby that is literally harmful. Right? Harmful, but now that is fine. That means now they have found several methods by injecting several antibodies. Now it is fine. We can cure, but we have to identify properly. Right? Okay. Within few hours of baby bonds, first baby bonds, then we have to put that injection. Otherwise, what happens when the first baby is born? Right? The first baby. Now, normally the mother's blood and the fetus or the infant, that blood is not getting mixed. Blood is not mixing. Okay. Blood is not mixing. Oxygen and everything is going, right? Nutrition and everything is going, but blood is not mixing. Clear, right? Blood is not mixing even in the inside the body, even inside the womb of the mother, right? Blood is not mixing. That's that you have to know. So blood is not mixing. Therefore, nothing happens when it comes out. What happens? The babies, what you call umbilical cord is then we are cutting that. So, right, in that case, some amount of blood, the bleeding will happen. Right now, it is very harmful for the next baby. That is what happens. Right? Okay. Right. So that is a big part. The rhesus factor recipient can receive, and that can be avoided, but you have to understand earlier. RH positive recipient can receive the RH positive and RH negative bloods. RH negative recipient can receive only RH negative blood. Highlight them and keep it. Right. So recipients they have given as a table again. Right. Then you see to donate blood, both the blood group and the rhesus factor have to be matched. Both. Okay. These are the two requirements to get matched: the blood group and the rhesus factor. Therefore, both the blood group and the rhesus factor is considered when exposing the blood group of an individual. Right. So when you want to take the license, so they will take the blood. That is the first place where you're going to get the blood report. So in that blood, you can see which kind of blood you have, or positive or negative or AB, something like that. Right. Okay. So then we have to know the blood agglutination. Right. So blood agglutination as actually, you see, clumping of blood, transfused blood particles in the body of recipient is called agglutination. Right. Clumping of the blood is like clotting, right? Or like getting destroyed. Transfused blood particles, right? Donor is giving the blood. Now recipient is receiving the blood, right? Clumping of the transfused blood particles, right? The donor's blood is going inside. That donor's blood particles getting clumped, right? Okay, they are getting like frozen and break down into pieces, right? Or destroyed in the body of recipient. The body of recipient, right? So when we give the blood, now these are not matching. If these are not matching, what happens? They're going to clump, right? Sometimes it might cause death, right? Because the body is identifying that like a antigen or a pathogen. You see, earlier I told you, no, right? Now the plasma cells start to attack like that, blast. So entire blood which is being transfused, totally going to be destroyed. That means you are insanely, you're going to die, right? So that is the thing that happens. What is the reason? Blood agglutination is caused when the blood group of donor and recipients are incompatible, including rhesus factor. Okay, right? You have to consider rhesus factor as well, right? So that is what we call. So clumping which blood? Transfused blood. The given blood only get clumps, right? Not the recipient's blood. the given blood, the donor's blood is getting clumped inside the recipient's body, right? Inside the recipient body, that is what we call blood agglutination, right? So this happens when bloods are not compatible or incompatible. Blood clotting or the coagulation means what? The process that prevents excessive bleeding when there is an injury or internal bleeding. Internally also bleeding happens, okay, in the mouth and here, right? Internal bleeding can be stopped by if you're having proper amount of vitamin C. Internal bleedings can be cured, right? But you have to have a proper amount of vitamin C with the fruits and the orange color fruits having this vitamin C, right? Then, so I told you about the blood clotting in the platelets part, right? Help with the platelets, the coagulation or the blood clotting, both are similar words. When there's an injury or bleeding, the platelets, okay, at the damaged blood vessels break down and the resulting chemical process forms blood clot to stop bleeding. When you go to A levels, this also you will study how these fibrinogen fibers are released and then how they form the fibrin and then how they form the mess of the blood clot. So everything you're going to study when you come to the big grades, right? So this is how blood agglutination and blood coagulation or the blood clotting happens, right? Blood clotting is a different thing. Blood clumping because of agglutination, right? That is another thing, right? When you transfuse only, the agglutination happens. Blood clotting can happen when you have a wound, right? That can be an external wound, that can be an internal wound, right? Some favorable habits to maintain healthy blood circulation system. What you can do? Maintain mentally less stressful life. Freely, funnily. You see, now when you're studying, enjoy and study. Just draw something, right? Whenever you like interest in several things, you do those things, right? So like that, enjoy, right? Each and every moment that you have to enjoy, right? So because this life is like, nobody going to give you the same time again, right? Okay. Once the time is gone, the time is gone. Again, this time won't come back again, right? So whenever you have that time, okay, you care your parents, you care your siblings, right? Okay, then study, focus on studies, right? Do something which makes happy, right? When your parents are happy, you always will, your life will be very successful. With experience, we are telling, right? Even me, the answer, right? Still, right? For whatever the age that is, right? You're still there, right? Once I like example, if I tell you, once in a judicial court, right? A person comes, he is 96 years old, right? He was founded, that means he was charged with the high speed near the school area, right? Okay, so they're asking the reason. 96 years old man, right? So he's telling, yes, I'm not driving that speed, but if I had to, I will. Like that he's telling, right? So then the judge asks why. The reason is, what's the reason, right? He is telling, I had to do some blood works with my child, right? Okay, the 96 years father, he's telling, I had to do some like blood works means like sometimes he might have a kidney injury or something. Okay, dialysis processes are there. So like that, he's telling like this thing. Okay, now what it means, and he's asking, how old is your son? Right, actually 63 years old. 63 years old son, right? He's taking him to the hospital, right? And it was an emergency, so he went with like with speed, right? You think 96 years old dad, how they're carrying affection and love, right? This is what parents means, right? Each and every day, they are spending money on you to study well, right? To study harder. But you have to understand these things, right? When you understand, and when you love this science or maths, whatever the thing you are studying, nicely it will go into your mind, right? Neither you hate science, not like that, right? Science is such an easy subject, but the perspective matters. Perspective means the angle what you are seeing the science, that matters. If you see it like okay, it's very nice, no? See, when you see the environment, when you feel the nature, see how nice it, right? How nice is it? So like that, if you feel, everything will be nice. Everything, right? Each and every day when you like feel like, yeah, I'm positive, I can do this, I can do this thing. Like that, if you feel, okay, you are the most powerful person in the world. You can achieve anything each and every day, right? Each and every day, do something new, right? Okay, study something, get some knowledge, right? Okay, intelligent and educated means two things, right? You can be wise, you can be intelligent if you study more. That can happen, right? But becoming an intelligent person, not only depending on studies, with the experience that is coming other side, right? So whatever the thing you are gaining, whatever the knowledge you want to gain, just gain them, right? Okay, even not for the sake of exams. You're not doing anything for exams, right? If I want to focus on an exam, you can't study anything. Why? As I told earlier, you will keep a tissue paper and you will trace the heart, right? Okay, you will trace the heart, and then you will by heart something. Okay, right atrium top, left atrium top, the right ventricles bottom, chambers bottom, septa is mid, blah blah, like that. You will by heart. But with practice, you see, you can easily study, right? Okay, right. Once Lord Buddha said this, as I remember, right? Okay, when you want to see what right, when you want love a flower, or like when you like a flower, when you love flower, right? When you like a flower, what will you do is you will pluck it and keep it with you. But within few days, what is going to happen, right? That will be like dead, right? Okay, but when you love it, what happens? You will daily water it, right? You will take care of that flower, right? Once if you see that one, you will feel very happier, right? Like that, you must need to understand, right? So whatever the thing you are studying, carry it like a flower. You water it daily. You try to update your knowledge, right? These things you have to know, right? Whenever you do these things, right? It's not only the way like by sitting on in front of a this thing and reading a book, right? You have several sources now, right? You can ask someone, right? You can go watch the environment, practically things what is going around. Whenever you study something, you see practical. Science is practical something, right? Okay. Whenever this is like I'm telling, okay, love dub sound is coming, you just keep your like, hand there and see, feel. Is it like true? Yeah. Right. So likewise, you have to go practically with these things, right? So whenever you become a good person, your parents will be more happier than you, right? That is how you have to achieve in life, right? Okay. So you are still young, you can study a lot, you have a lot of time, not like us, right? When you come to our age, you will have a lot of stress in your mind, right? Lot of stress, you will have a lot of works, right? The university works, your students work, blah blah, parents work, everything is there. Responsibilities will come. Now you are free, right? You can do several things, right? Okay, freely study, freely do practicals, freely study everything. Just love studying, right? Whatever the thing you are studying, just find the reasons, facts, why I won't study this, why I'm studying. Same time you improve your skills, right? So this is how you can be stress-free and be happy, so that no any problems will come to your blood. That means no heart attacks, right? Next one, engage in physical exercises daily. Do some exercises daily, just jogging, like walking, or at least like do some helps to sweep the home, right? Help parents, right? You can mop the home, you can sweep the home. And I can remember in my childhood when I want to watch a kids movie, what I'm doing. So 7 o'clock it sharply starts. So before 7 o'clock, okay, by waking up at 5:30, read 6, 7, 8, 9, those areas, right? I have to sleep, right? Me and my bro. So what we have to do, we have to sleep and the mob and go to the shop and bring bread and everything. Then after doing everything only, they will let us to turn on the TV. Otherwise, they won't let us to turn on the TV, right? Okay. So like that, right? That you will be like in a good disciplinary manner when you're doing like those things, right? So then fine, right? So we are doing early morning everything, right? So that is an exercise, right? Play, evening play. Don't play these games in mobile phone, PUBG, blah blah blah. These will eat your mind. Okay, these fireflies, blah things are there now. Okay, fire free or free fire or something, right? These things, don't play those things, right? This you will end up blinding your eyes, end up your lifespan getting shortened like 50 years, 45. Finish. Right? Okay. Sometimes the tumors, cancers, right? Because of these rays, your allergies and everything. So these kind of things might happen, right? So just throw them away. Just enjoy the evenings, right? Okay, go and play with your friends, right? Do that things, right? Don't be at home as a homesick people and keep watching these movies and keep watching your phones, mobile phones, and don't do these things. This is just in me. For your age, you just enjoy, right? Just enjoy the life, play with friends, right? Okay, whatever the time you can spend around with parents, because that chances will not come again. When you come to our age, that chances are not coming. That is very small amount that is coming, right? Very small time that comes with like to talk with your parents and all. Talk anything, talk open-mindedly. Tell that I love you, right? Okay, go and tell. So that makes sense, right? That makes sense. Spend time more with them. Spend time more with studies, right? Enjoy. You don't have responsibilities, right? Be very free, right? And they also will not get stressed. Don't do the things like to get scolded by them. When you do like this, what is happening, right? They are losing their happiness. Why I give born to this kind of child like that? Don't make them like that, right? They are giving such facilities. They are giving our data. They are giving the mobile phone. They are giving the laptops to study and do all the purposes. You have to understand, right? When you understand, you can do a lot. Okay, you can give them a lot, right? Try to make them happy, right? So that you automatically you will be happy. You don't have responsibilities. Okay, so that enjoy that. Then engage in physical activities daily. So you do like this in help parents and go and sweep, anything you can do, right? Or run, do exercises. Yeah. Then reducing salt consumption, right? So normally we Sri Lankan people, we are used to salt when we are eating rice, right? So we can we have to take salt in required amount, but exceeding that is not good. It will increase the high blood pressure, right? So that is ending up with high blood pressure. Okay, right? So that is increasing viscosity in the blood, thickness of the blood, right? And several other things. Controlling conditions like high blood pressure and diabetes, right? Diabetes is one of the worst things, right? I've experienced that a lot, right? Because of my dad, right? So when is one you get a wound, right? It will not get cured easily, right? Okay, that will take a lot of time. You have to struggle. You have to do lots of things, right? Okay, when you have diabetes like these conditions, you will get mentally down, right? And the blood pressures, right? Why the blood pressures are coming? When you are not happy, the blood pressure is coming, right? When you are happy always, keep smiling like that. Every time you will be happy, right? So you don't need a problem. Don't hate others, right? Even when they hate you, it's like, you're fine, I'm fine, okay, totally fine. Like that, you'll be like that, right? So you see, when a snake or something is going towards the fire, okay, it will get burned. What you do, you will help, right? You just throw it away, right? Burning is not good for anyone, right? So you will throw it away. What is the habit of the snake? That is biting, right? When it got fear, it will bite. Okay, that is the quality of that. So that will keep biting. But it is your quality, your good quality. Just throw it away. That's all. That is his quality. This is my quality, right? If you are a good quality person, if you are a good comrade, actually, right? You will be nice person, wise person, and happy person, right? That is what we want out in our life, right? Okay, so we can control these kind of high blood pressures and diabetes like these things when we are very happy, when we enjoy, when we exercise, right? When we live happily. Okay, living happily means not operating mobile phones. In your age, I don't have a mobile phone, right? Even I never thought about a smartphone. Those days we don't have smartphone devices like this, and we were like semi-happy, not happy those days, right? So you must need to understand that. Now the students, they are thinking, right? I have mobile phone, I have Wi-Fi, I have laptop, everything. Now I'm happy. No, actually you are not. But you don't understand that. That is the thing. No, sir. We are modern. No. Those days, stupid works and newbie doing. And now we have the technology and everything. Yeah, technology and everything. The lifespan is decreased. Right? Ask some old people, 102 years, 103 years, 105 years, 110 years, people are there who's living like that. right? Without glasses, they can read anything. Some people are there. Why? Right? They didn't use these smartphones. They enjoy the life, right? They are living with the nature to do like that, right? So you can decrease the stress and everything. Right, controlling conditions like high blood pressure and diabetes, I told you. Adding more vegetables and fruits to meals, right? So when you add more vegetables and fruits to meals, you will get enough minerals, enough vitamins, enough everything, right? Okay, in these vegetables, okay, eat less amount of carbohydrate, that means rice, little amount, that will provide you energy. So eat little amount of rice with big amount of vegetables, right? Then only you will get a high, like you will get a good healthy diet, right? So that healthy diet will provide you to be a strong man, right? Next one, reduce consumption of fatty foods, as I told you earlier, right? Okay, coronary arteries will be blocked and new finish, right? So that we call myocardial infarctions can come, right? Recently, one of my uncle, right, he got that out of five, like in five coronary arteries, there were blocks, and out of one of that, 99% block, right? Normally, he's doing activities, he's walking and he's doing everything, right? And he also liked a little bit of like fatty cutlet and all these fatty things, right? So what happened? Okay, it's like a normal person, but things might happen, right? And then he has to undergo with the bypass surgery, right? So in the bypass surgery, that they will get a vein from the left side leg normally. So then they will bypass it. So like that things they are doing, okay, we can do. So right. So better to avoid these conditions, right? So sometimes first attack, some people die. Sometimes second attack, heart attacks, they die. Sometimes third attack, they die. Right. So you don't have to get medicines. Why you want to give money and take medicines and to get killed yourself, right? So better be happy, do exercises, okay? Consume less amount of that these fatty things, right? When you get biryani or something like that, what you can do, you can just drink a hot water, good, right? So that is good. Consume hot water. Don't take cold waters like that, right? Otherwise, you will go find your what the diseases, right? Now, refrain from smoking and liquor, right? Refrain from smoking and liquor, right? And each and every single thing which is harmful for your body, right? Okay, so smoking causes cancer, smoking kills, that everyone tells, right? Especially not the people who's smoking, who's nearby that, they will get more effect from it, right? Okay, if a pregnant mother is there, if somebody is smoking, that the gas is going into the fetus, infant, right? That much, right? Nicotine and everything is there. That is very, very harmful, right? It is cancerous and they might cause you death, right? So, and the other thing is the liquor, right? Other harmful thing. You will lose your conscious mind. When you lose your conscious mind, what is happiness? Nothing is there, right? So you have to be conscious and then you have to experience the life and you can go with everything, right? So that's all I had to tell. Some favorable habits to maintain healthy blood circulation system. So these kind of things, when you maintain mental free, stressful life, engage physical exercises, reducing salt consumption, control conditions like high blood pressure, diabetes, and everything. More vegetables and more fruits to meals, and add reduce consumption of fatty foods, right? Lipids and all, different from smoking and living, right? So we have this thing also. So have a healthy heart, can control cholesterol, control blood pressure, smoking. Okay, if someone is smoking, it's go and tell, right? This is impacting others more than yourself. And then when you smoke, your lifespan is decreased by 5 to 10 seconds. Now it is more than that, right? Managing weight, can manage your weight and consume food, and daily get 7 to 8 hours sleep. When you come to our ages, the sleep will be less, right? Therefore, you have to get a good sleep, right? Okay, and at last we have the normal timetable, what we are doing. All every Sunday, 11:30 to 1:30 p.m. we have the normal theory class. And this was the lesson that is going on. So now totally it is finished. Now next lesson which we have to start is the 7th lesson, right? Growing substances for plants, right? The 7th lesson we will start by the next coming up Sunday, right? So this is a total lesson, human circulatory system, and you see about the heart. You know how to draw the heart. You know what are arteries. You know what are veins. What are capillaries and what are the components in the blood, and you know what is the purpose of these RBC, plasma, and everything, right? And you know how the blood transfusion happens, who's a donor, who's a gainer, like who's a recipient, what is the rhesus factor, and what kind of things we have to do when we want to maintain a healthy life. Is there any questions with you? Any questions? Any doubts? Is it all clear, Vijay, what I was telling today? Is the lesson is clear?
Yes, sir. Yes, sir.
Yes, sir.
Right. Everyone can talk.
Yes, sir.
Right. Clear. Is it interesting or boring? It's like, see, no?
Interesting.
Right. Right.
Yes,
If you
yes,
feel that is good, right? Everyone is open, right? Open to put your comments. Comments means like in WhatsApp, you are there, no? So in WhatsApp, you can put in the group, or you can send it to us privately for me and Rehansa especially, right? Okay, Rehansa will keep motivating you on every Wednesdays. Every Wednesdays, Rehansa's motivation sessions are there. Better to join that, right? So you can be motivated, so you can work like a beast, right? So every Wednesday that is there, so he will drop you the link, right, on Wednesday, so you can join to that session as well. 5 to 6 evening, these motivational sessions are there, right? That is how Comrades are going, right? So you can leave the comments in not in here, means the group, or you can leave the comments in privately. You can see who are the admins. Me and Rehansa only the admin. So a team Comrade name, that means Rehansa's, and the other that admin is me, right? So for that, those two things, you can save that number and you can send me the messages by telling who are you, right? So just let us know, right? What are the comments and all, right? So last 2 minutes are there. If any one of you having any problem, any question, anything to tell, you can, before we winding up the seminar. Do you have
Also,
anything?
you can introduce about the theory class, the timetable and all. If anyone like to join, can join.
Yeah, if anyone likes to join for grade 9 theory class, timetable is on every Sunday. Every Sunday, 11:30 a.m. to 1:30 p.m. Right? Okay, that will be done by me. And grade 10 also there. Grade 10 on Saturdays morning 8 o'clock. Maths class for grade 10 on 10:30 to 10:30 to 12:30. And grade 11 science class is on Thursdays night 8 p.m. to 10 p.m. And maths class for grade 11, that is on Tuesdays 8 p.m. to 10 p.m. Like that you can join. The grade 9 class is on Sundays 11:30 to 1:30 p.m. Right? So in that time only we have, and the 7th lesson we're going to start. If anyone wants to join, you can join. Okay, and you can ask further more details about that with Rehansa. So Rehansa will provide everything, the required details and all for you, right? If you're interested, you can join and see the difference every time, all the time. That will be going, sessions will be going like this, more interactive and with video segments and everything, which is clearly understandable, right? Okay, so if you want to study and if you want to enjoy the studies and if you want to be motivated, you can join the comments, right? Hope you all got a good session, good seminar, and then we'll see you by the next session, and have a nice day. Bye. Good night.